know, man. But it's very sophisticated. So that's cool. Let's see, what was I looking for? Oh, the
There it is. Now we're
yeah,
live.
nice in the field.
My
Oops.
bad. This is my first time scheduling it ahead of time.
Oh, you're straight. Yeah, sometimes you have to confirm it on the YouTube end.
Yeah, now I know for next time. My bad.
Yeah, dude, I went through a similar process where I lost like 3 or 4 presentations and streams.
Ooh, that's rough.
Yeah, it
Well, yeah,
wasn't good.
anyone that's listening in, thanks for being here. Alan is going to take over here and present some information regarding E equals MC squared. And we're also going to discuss some more information that Robert Bennett shared last week. But yeah, thanks for being here. And go ahead, Alan, whenever you're ready.
All right, sir. So I got the. If you tune into the stream thing, you'll hear the audio. If you just watch the webcam thing, you'll just see the video. So keep that in mind. So go ahead and tune into the stream thing, and then I'll play this out. Let's see, I should have loaded it on YouTube so I could see where I'm skipping to. Yeah, right here. All right, playback faster.
None of this is correct.
Yo, what up, Sacred? Shout out to the level heads in the chat. I don't know if you guys have the links or you can, feel free to join in the voice chat if you're available. Here's the links. You guys are always welcome. Shout out to the boys. All right. Here's the experiments.
Explained. In 1971,
All right.
it was performed by a man named Jones. This is an experiment that I had to dig out from. It was really buried in the documents. It's very hard to find, but it's an example of how mainstream will ignore anything that contradicts the current belief. Let's go through this experiment. It consists of a plexiglass or lucite disc, clear plastic. There's a source of light. Let's say it's a laser. And with the disc at rest, the path of the light goes straight through the disc, which is the dashed line, reflected by 2 mirrors, back through the stationary disc, and then into a detector, an eyepiece. Okay, so you see the location when the disc is not rotating. Then you set it rotating at an angular speed omega. Okay, but the light now is deflected, almost as though it were refracted, but there is no refracted. There is no change in media. We still have the clear plastic here, but the light is now bent the way it would be if we looked at a light beam at an angle going into water. So there is an angle formed here, again, double mirror reflection. And what is the purpose of going back? Well, this doubles the effect. So it happens here once, and then the angle is deflected again, so it makes it easier to see the result. This is what you see in the eyepiece. You see the beginning at rest, and then you see the shift in the position of the light beam to the side. And the explanation for this is the rotating plastic drags the ether around with it, creating an ether whirlpool or vortex, and it's that drags the light, which travels in ether and travels in a frame of reference in which the ether is at rest.
Yeah. So that's crazy, man. And that was that's so straightforward and like to the point. And that was Sagnak's understanding, right? So with his, I don't have, let me see if I can get the equation up. Second. So with the way that the rotation, the fringe shift pattern produced, right? The variance in the speed is proportional to the rotation of the device, and that's what they were showing there. So like that rotating disc has its own ether whirlpool, and that's what that's what Sagnak's understanding of it, right?
I mean, when I hear that, it kind of just sounds like common sense, right? Like it would drift with the disc.
Yeah.
But I guess that just refutes relativity to a sense, right?
Well, in particular, because Einstein specifically said that any closed polygonal circuit that's in uniform rotation is an inertial reference frame. So like he really GG'd himself, and
Yeah.
that's why they. So it took after 1913. It took until 1917 for special relativity to derive the solution to explain it, and then a year later, Paul Lavue came out with a metric tensor to explain it.
More kinematic nonsense.
Yeah, due to an insane degree, which we're going to get into towards the end of the presentation with the E equals MC squared. We're going to get into first order invariant different or first order intrinsic differential invariance. We're going to get into those because that's going to become a main factor in these kinematic solutions. Let's see here. So where was that linearized equation here? Let's see. So this is like the full reduced form of what Sagnac was saying. So delta t equals 4 times the angular rotation times the area of the path of basically the path that light has to travel over c squared. So the dependence of the fringe being the angular rotation and the path that light has to travel. So that's basically what they showed in this same situation. So as this is rotating faster, more fringe gets produced. The whirlpool, the drag, the translational motion from the ether, relative to what's rotating, is causing a variance in electromagnetic propagation. So the only way that would happen is if electromagnetic waves are propagating through that ether, and they're like tied together, right? What's up?
No, all good, all good.
Oh, okay. All right. Yo, what up, Stephanie? Yo, Ubercast. Not a debating, or is this a dating stream? I don't know what that means. Let's see. Dating stream. Yeah, it's a ether cosmology. I don't know. All right.
And travels in a frame of reference in which the ether is at rest. A classic test of ether is the Fresnel.
Now I've heard of this one, but I never read it or looked into it because the name starts. It's like Fresnel. I was like repulsed by it for some reason. Never looked into it, but this is an awesome experiment. This is a great experiment, if you will.
Drag test, 1851. The situation here is we have a pipe full of water flowing in the direction as you see. Then you have a setup that we'll see later. It's basically the Sagnac setup. A light beam comes in here, and it's split into 2 half beams. One travels opposite to the direction of the water, and the other one is reflected, so it goes in the same direction. So here, the light beam is boosted by the speed of the water, and here it is delayed. The 2 beams are united right here, and if there is a difference in the speed, then there will be an interference pattern. And the number of fringes in the pattern determine what the speed difference is between the 2 waves. Okay? Now here's what the experiment showed. This is the formula that Fresnel derived. The speed of light divided by the index of refraction, in this case, water, plus the speed of the water times 1 minus 1 over the index of refraction squared. Well, let's check this. What if we had a vacuum? Then n would be equal to 1. So this would be c. N squared would be 1. 1 minus 1 would be 0. So this would be 0. So we get speed of light equals c in vacuum. All right, so that checks. Put in n equals, 4/3 for water. And you get 0.75 c plus 0.44 v. So Fresnel's law shows that, again, it's the ether that determines what the speed of light is, because the water is dragging the ether along with it. The arrows that we see here represent the speed of the water, but we now know that the ether, which we cannot see, is also being dragged at a speed c. Now the Russians.
All right, very cool.
I mean,
then I'll let. Sorry, go ahead.
Seems like a pretty big GG right there.
Yeah, I mean, direct translational speed dependence, like first order measurement type stuff, where it's like, oh, this was the cause of it. You know what I mean? It's like, what do we do with that? Well, we're going to kinematically wrap it up in tensors that no one can understand and call you stupid if you don't capitulate. So here's the Russian Galev ether test. Now, this is really cool here. So from this diagram, I'll let him walk it through, and then I'll kind of give a quick little reiteration.
I should say a few things about the Russian science. First of all, we don't hear much about Russian science. You probably heard of Mendeleev, who invented the periodic table, but not much else. It's not because the Russians are retarded in their scientific ability. One of the problems, of course, is the language. If you have any Russian science documents, they have to be translated. And this is before machine translation, so you had that was a problem. You had political problems, that getting Russian documents was difficult because of, Russia was considered bad and United States good. So Russian.
Oh, dude, how could they compartmentalize the whole world? How could they all be in on it? Yeah, I don't know, man. It's crazy, right?
Information was
They just tell you that the Russian people are the bad guys, like and like you won't even look into the stuff they say, you know.
Censored. But what we find is very interesting. The way that the Russians do science is not the way we do it. In order to review a new theory or a new experiment or any new topic, what they do is gather in conferences and they debate mano a mano whether what is being presented is true and whether it should be considered mainstream. In the West, what we do is submit documents to a peer review panel. Usually they're unknown. We don't know who they are. And this sounds like a great idea because your ideas would be evaluated by your peers, by people who do the same kind of research that you do. But what has happened over the years is that these peer review panels have become censorship boards. In other words, it's a way of canceling or preventing any new ideas from being presented to the public as mainstream ideas. So let me go through what Galileev did. He did some tests with radio signals. Now remember that radio signals travel at the speed of light because they're electromagnetic radiation. So what he discovered with radio signals should apply just as well to light or to infrared or to X-rays or any other radiation. Consider an elevated point A and send a radio signal to B and record the time. Then send it from A to, let's say, a reflector on the ground C, which then is bounced to B. So that takes a longer time. But the difference in the time is not just the distance. They find out it also depends on what the ether properties were as the light signal passed along the path. Here's another path hitting a mountaintop D and then going to B. So by choosing all these different paths and seeing how it changes, Galileev could determine different properties that ether had. And here is an indication of one of his measurements carried out in sidereal time, which means according to the rotation of the stars. In a 24-hour in sidereal time, he sees a pattern of change in which the energy raised of the light beam increases and then decreases to almost the same amount as it was here, and then it repeats. So what he's finding here is, number one, that there is an ether that is changing, an ether wave, an ether cycle, which has a period of 24 hours sidereal. That is, it's our 24 hours minus 4 minutes. The fact that it's sidereal means it's coming from the stars. It's not coming from the sun. If it was coming from the sun, then this pattern would repeat every 24 hours exactly, not every 24 hours minus 4 minutes. Very sensitive. All right, this chart just shows different measurements that he took, the height above the Earth's surface, and the different experiments and what his results were. This is an example of Russian science, which we see very little of. The other Russian scientist that I'm very much interested in is Atsukovsky.
So then he goes on to talk about a little your boy Atsukovsky. But so what was going on here was the translational speed, coming from the sky, right? As you increase in altitude, the readings get stronger. That's what Miller found. As you get it into a subterranean level in a basement, like a Michelson-Morley situation, right? The readings become reduced. So what Galileev's ether test was doing was measuring at altitude, basically, the fluctuations at altitude for for that translational drop-off speed. So similar to how that ether plastic test with the rotating disc, right? So it would be like equivalent to saying, well, how much of that translational speed is like how high or how far away do you have to be from that rotating plastic to stop receiving that full rotational speed variance, right? So another example of that would be in the DeFore and Pruner. Let me pull it up real quick for the visual. DeFore and Pruner, ether wind, Pruner. All right, so it would be the equivalent of they did their experiment where they had the rotating apparatus here and
This
then
isn't
a
on
fixed frame up.
your screen share. I don't know if you need
Oh,
to. Which
yes,
is fine. I can switch over. I just want to make sure you knew.
yeah. Thank you. It's actually only really important for the visual here because there's no audio to this part. So if you just want to like look at the webcam.
Yep, got it.
Okay, cool. All right, so the rotating apparatus here at the bottom, this rotates. This top part is fixed to the lab, and then the detector and source of light are fixed to the lab wall as well, right? So, and this is only four inches above. There's only a 4 inch separation here. So the question would be like, would there still be a first order dependence on the rotation if there was 10 inches, 15 inches? Like how at what point is it going to like not matter and the speed of light will just be not affected by that vortex or something like that? You know what I mean? So that's kind of what Gallup was kind of doing, like the extreme of that, right? Using mountains or like doing it at mountains and then like reflecting it at angles so that it's like propagating at a certain elevation for a period of time.
Yeah, so
Does that
he's
make
not
sense?
using that device, right? But this is corroborating those measurements.
Yeah. Well, this is like further breaking down like that. They're further answering the question that like what would happen if you increase the distance between the rotating apparatus and the stationary device, right?
Got it.
So yeah, so through doing that, he kind of measured a variance in the translational speed. We'll have to like dive more into that, but that's what he was measuring. And then again, when he plotted one of the measurements against sidereal time, the dimensions reach their minimum and maximum dimensions in correspondence with sidereal time. So GG. All right, so I think that's all I wanted to show on that for those because those are awesome experiments that really just show you what's up, especially your boy DeFore and Pruner. I can't wait until I think in part two of the presentation, he's going to get into DeFore Pruner and the Wang stuff more in depth with the kinematics and dynamics. Like I'm super excited for that.
I
That's
mean,
going to be
we're
insane.
like still digging into the first one. Yeah, it's
Yeah, dude, I know.
guaranteed
I'm
to be
still,
so good.
dude. I've watched the first one like 4 or 5 times now. It's the best. So let's see here. What were we doing now? Oh, the E equals MC squared, right?
Heck yeah.
All right. We can go ahead and I can stop sharing that. Then you can just do it off the webcam, I think.
Cool.
All right. So we're all told that E equals mc squared. So this is energy equals mass times the speed of light squared. So there's this proportional relation. Well, that they're intertwined really through the what is it? The equivalence principle, right? So that's the relationship that Einstein's trying to establish there, and we're told that this relationship is physically meaningful, and that out of these equations somehow an atomic bomb was created, right? This release of energy that describes this proportional relationship, and they were able to capitalize on this equation or what it means or whatever, right? So that's the kind of story we're told. So we're going to examine the validity of that claim and the history of the equation and what it means and all that. So this is in relation to something else, but anyway, the mainstream claim here is that these equations have physically managed themselves and were utilized to create an atomic bomb, right? Like the principles, not necessarily those equations are like the reason for the atomic bomb, but the principles that they represent are that's like the technological pinnacle of those equations, right? So before Einstein published his 1905 paper on special relativity and unveiled the mass energy equivalence and all that, your boy J.J. Thomson was doing some experiments in 1897, and on this, it was with the was it a cathode ray and a cathode tube, and what he measured there was the behavior, so to speak. He described the behavior of the mass of an electron, I think it was, um, as if it had gained weight, right? So, and we'll talk about what that means here in a second. So, we'll read from it. This causes the charge of the body to behave as if the mass were increased by the quantity for which the charge sphere is 1/5 e squared over mu a, where I forget what that one is. The E is the charge potential, and I cut it off. Okay, yeah, E is the charge potential, A is the radius of the sphere, and I forget what the mu was here. But anyway, I think that was the magnetic permeability, probably. I'm guessing. So, it's because what he was doing basically is he was shooting electrons at a magnetic field and increasing the strength of the field and decreasing it. Um, the trajectory of the electron, so to speak, would vary. And so what he was doing with that is he determined that the that there was like mass to it or whatever. Like that was his explanation from it. That was kind of what he was extrapolating. So this is like an early rendition of E equals mc squared with J.J. Thomson. So, I have slides for it. Nice. So, by using an electric and magnetic field to direct and deflect the charge potential of a cathode ray, J.J. Thomson was able to mathematically extrapolate a charge to mass ratio based on the degree of deflection. So, this is again the early rendition of the behavior of saying that it's that's what it's describing, right? So, does this mean that there's a Chinese charged particle that its physical mass has increased? So no, the accelerating charge potential changes when the impedance, the electric permittivity, and the magnetic permeability changes. So the behavior as described by J.J. Thomson of the mass increased as a kinematic effect. Dynamically, the change due to the permittivity and permeability are responsible for the deflection of the apparent charge to mass ratio, in my opinion. So that's my explanation for it. And then we have, I think, read this out just to make sure I'm not missing anything. Sorry, this is kind of a dry run on the presentation, and I got some of it in my head, so I'm just kind of going with the flow.
No, that's cool. It's cool. It's making sense.
Okay, cool. All right, so it's in the neighborhood of its neighborhood. Moving the body involves the production of the varying electric field and therefore a certain amount of energy which is proportional to the square of the velocity. This causes the charged body to behave as if its mass were increased by the quantity for the charge of the sphere is 1/5. Yeah, so that's the fuller context of what I ripped out earlier. Let's see. And then if we were to assume if the mass that if this is if we assume that it is the mass that which we are concerned, that in the cathode ray, that would mean that m divided by E would vary as the electric charge divided by the radius. It affords no clue to the explanation of either properties of 1 and 2. And then 1 and 2 were possible explanations that he went over at the beginning of the thing, which I'll have to include, I think. I don't think I have them at the bottom.
I'm so glad we have the clear distinction now within our local vernacular here of kinematics and dynamics. Because
it's a game changer, bro. When you realize like the difference between the implications of like a coordinate system transformation and a reference frame, where it's like implying an actual observer, where you're going to plot out real forces, where things have to matter. You know, you can't just invoke some contraction that may or may not be happening, or may or may not be physical, depending on what reference frame you may or may not be in. It's like, all right, dude, like, let's dial it back a little bit on that. All right, so we have I've Stillwell did a couple papers on this mass. I'm sorry, on E equals mc squared. And he pointed out that some other guy also derived it in 1904. So I'll read off that real quick. So the first explicit statement that the heat energy of a body increases its mechanical mass was made by F. Hasenauer, hopefully that's his name, in 1904. Hasenauer studied the problem of a hollowed enclosure filled with radiation to determine the effect of pressure due to the radiation. He showed that to the mechanical mass of our system must be added an apparent mass of what is that? Mu. I think that's mu. Mu equals 8e over c squared. Or I'm sorry, 8e over 3 times c squared. So this was later recalculated to e times 4 over 3 times c squared. Then on the ground that the internal energy of the body must consist in part of the radiation, Hasenauer, the cool name, stated that the general mass of the body will depend on its temperature. So there's a description here where this guy found, an apparent mass increase when you're heating up a body due to pressure, right? That this increases the apparent mass, and he has his equation here for the derived effect. This is another rendition of somebody like not only dude. This is so crazy here too, because Einstein's paper, he makes no citations, bro. He just comes in hot with this full theory of everything. Like he just whipped this shit up. Like oh, you know what, dude? I was thinking about this last night. So just whipped it all up together. Like these are people that did experiments and then like are trying to describe a relationship with the behavior, and they're very specific in their wording. Like this is an apparent effect. The behavior, it's almost like it's reacting like blah blah blah, right? These are kinematic descriptions of the behavior, right? And then Einstein's going to come in hot with his 0x citation paper and say, "Hey, you know what? These are actually real effects as soon as we transform into this new coordinate system." All right. So Ives, again, from the paper Derivation of Mass and Energy Relations. So this is him going over the mathematical proof that Einstein provided for E equals mc squared in his paper. And he comes to the conclusion that Einstein couldn't possibly have proved E equals mc squared with his mathematics in the paper, because they had to use circular reasoning to already assume that the theory was correct. I mean, he goes over it in detail, and the mathematics are all in there. So I just kind of took excerpts of what he was saying to just kind of reiterate here. So Einstein, in the work referred to in 1905, did not give his derivation. So he just showed up with it. That's cool. And he did not use the momentum of the radiation. So this is in regards to like which reference frame was selected and how to conserve the momentum and balance out the equation properly as he's laying out the framework for this, because the conservation laws, are super important. Like they need to be accounted for. No one's going to accept the theory if it doesn't have a mechanism to explain that stuff, right? So, um, this is like pivotal to everything, right? Because what he did, well, I'll get into it. So let's see which is an essential element of this example, and his derivation was actually incomplete to give the result announced, and this was brought out in the appendix in this paper. So again, you can go over his paper and look at the mathematics and the transformations, and it's not he doesn't derive it right. He just shows up with it, uses circular reasoning to to facilitate how he's mathematically deriving it, which isn't how you do things apparently when you're actually doing science allegedly. So we got this guy points out in a book, Secrets of the Æther. So he makes a nice little analysis of the equation and like what it means in terms of the when you break it down to the units, right? So a little miniature unit analysis, if you will, of it. So energy is a unit, mass is a dimension. Energy is composed of dimensions of mass times length squared times the frequency. So this is the way that he defines um, mass and all that in his ether theory. So mass is not converted into energy, and energy is not converted into mass. Mass is merely a dimension from which units are constructed. This is repetitive, but understanding mass as merely a dimension is perhaps the greatest intellectual physics challenge for most people coming out of the 20th century. Because mass and energy are proportional, right? Because like we've all been hypnotized into that. But like just a basic unit analysis, it's like they're not describing the same measure. They're not describing the same thing. One's a dimension of something, and the other one's like frequency, energy over time and all that kind of shit. It's not the same situation. So he goes on to say, he makes this really interesting point, and I'll go over the citation that he provides and my thoughts on it here. So the conversion factor for E equals mc squared. So where's the validity of this equation? Where is it physically manifest other than the historical narrative of atomic bombs, in which the nuclear fallout story has changed over the years as the radiation poisoning has not manifested from these equations that supposedly manifested the explosion. So we often refer to nuclear reactions on the sun, nuclear power plants, and nuclear bombs as example to mass to energy conversion. In the nuclear power plant in nuclear power plants in the United States has in in the nuclear power plants the United States has been operating for 60 years. A high degree of precision applies to the measured amount of energy and the material mass passed through the reactor. And yet there is not one report available where that this writer has been able to obtain that presents data from a nuclear power plant and shows that the mass of the fuel was exactly converted into energy according to E equals mc squared. One would think that to prove special relativity theory, the data from a precisely monitored nuclear power plant would provide an abundance of evidence. Nevertheless, such data apparently does not exist. So then he goes on to talk about a violation of the conservation law. In fact, there is evidence to suggest that more energy comes out of a nuclear power plant than the fuel mass that goes in. A liquid, and the citation given here is a liquid metal fast breeder reactor once operated for 25 years and produced more fuel in its byproducts than it consumed during its operation. And then the citation here. So the EBR2 is by definition a liquid metal cooled fast breeder reactor. It is cooled with a molten sodium metal, and its chain reaction is perpetuated with extremely energetic fast neutrons, and was designed with the potential for breeding more fuel than it consumes. And then the Argonne National Laboratory, the West EBR, to 16 years of operation, right? So I tried to track down this citation. I couldn't find the 16 years of operation title. I found one for 20 years, 25, and 40, and no phraseology or data that seemed to indicate that this part was true. But that's what this guy was saying, and that was his citation for it, and could not substantiate it. But that's an interesting claim about the conversion factor in general. You would think that there would be something to substantiate that, right? If E equals mc squared
Yep.
was actually like an applicable thing that they were using. And then I took some pictures of the diagrams of the reactor because I've never seen one before, and I thought it was cool. So just share those. So this is the facility. There's some turbines here. There's your reactor core, and there's some other stuff over here. And then we'll get into what the reactor is. So, and again, not nothing super pivotal to the arguments here that I'm aware of, but just thought it would be cool to share the diagram of the reactor. All right. So, any questions so far, lads?
Well, so I'm thinking I thought that was a really interesting point about energy output and how you should be able to measure E equals mc squared at like a nuclear plant. But then I'm thinking also, don't they when they just explain it all away with inefficiencies in the steam turbines and heat being output through all the pipes and such?
Yeah, absolutely. They would, but you would also think from that they could kind of come up with a way to say, like, okay, this is the predicted amount of loss due to
Okay.
mechanical mishap or whatever, and this is the actual conversion, and I bet you that it's not even close enough to like even pretend. So
yeah, it's
I bet you
really
that's why
interesting.
yeah, that's my quick 2 cents on it. Because if it existed, I mean, that'd be a great proof to be like, look, your boy Ein was right. Other than this like mythological creature of two bombs that may or may
Yeah.
not have fallen out of an airplane and detonated, you know. So, all right, cool. So we'll look at your boy Ohanian's. Did Einstein prove E equals mc squared? So there was 6 times in over the course of 40 years where Einstein tried to correct his E equals mc squared situation, and each time he submitted the proofs for it, they were insufficient and weren't applied correctly. And 2 other people actually had to come in and save your boy. And these two, your boy Max Lau and Felix Klein, stepped in and were able to derive it. And we'll get into the derivations here because it's cool that they were able to solve it, but we're gonna find out that like it was a fool's errand or whatever the whole time, as they say. So just read off here from the abstract. So although Einstein's name is closely linked with the celebrated relation of E equals mc squared between mass and energy, a critical examination of more than a half a dozen so-called proofs of this relation that Einstein proved over the span of 40 years reveals that all the proofs suffer from mistakes. Einstein introduced unjustified assumptions, committed fatal errors in logic, or adopted low-speed restrictive approximations. So, kinematic expressions to make the mathematics appear like he's calculating for an effect that isn't real. He never succeeded in producing a valid general proof applicable to a relativistic system with arbitrary large internal speeds. So with the low approximation speed, there was one where he didn't even use relativistic speeds, and he was like, "Boys, it's all proportional, I swear." In the first general proof that was produced by Max Lau in 1911 for closed systems with a time independent energy momentum tensor, it was generalized by Felix Klein in 1918 for arbitrary time dependent closed system. So the history of that. So it's like, did this equation even come from Einstein? Because it's like it's all tied to him, and it's like it turned out that he wasn't able to even derive the effect that he was, describing from. Because dude, with no citations provided, right? It's like he just thought all of this up. And it's like, oh, cool. So then, like, there must be a logical consistency to the mathematics that he provided in his paper that shows how he was able to derive this as a consequence of relativity. And it's like, no, it turns out that it was all ass backwards, and for 40 years he couldn't do it consistently.
Yeah, it was like it's so crazy. It was like accepted before it was tested.
Yep, it just had to be because it just. Well, we'll get into it here in a second because we're going to start tying into. Let's see, it goes on for a minute. Yeah, we're almost done though. All right, so another excerpt from the paper here. So Einstein's 1905 derivation of the celebrated relation between mass and energy is widely regarded as one of the most seminal contributions to modern physics, but he cannot be awarded priority to proposing the relation. Some years earlier, J.J. Thomson, Abraham, Poincare, and Lorentz had recognized that the electrostatic energy of a charge distribution is endowed with mass and has proposed apparent mass. I'll say. Let's see, and has proposed that for all mass, um, an electron, or that there's a charge ratio proportionality, right? And then your boy Hazelhorn or Hasennorl had
Big
shown that
H.
had recognized that electromagnetic radiation in an enclosed cavity contributes to the inertia of the cavity. So the apparent weight of the cavity was changed according to the pressure in it, right? All right, so who proved E equals mc squared? Einstein returned to the mathematically proved it, not experimentally, by the way. This is just for the mathematical derivation from that paper. So who proved it? Who done it? Einstein returned to the mass energy problem in six other papers, one in 1906, two in 1907, and an unpublished paper in 1912, and two other papers in 1935 and 1946. And all the citations are there for that. So these reprises are in themselves an indication that Einstein had some suspicions that the proofs were unsatisfactory. Didn't Feynman say that one good proof is sufficient? Sure did. Feynman says a lot of cool stuff that's often quoted by relativists, and then when it doesn't apply, or like when it doesn't go in their way, they're like, Feynman who, man? Like that, never met her. So, because he was also the guy that said if the experiment doesn't match the theory, you throw that shit out or whatever. But they're like, well, hold on a minute. Like, we're not going to throw out the whole heliocentric model and Copernican principle and all that, you know. But everything else, though, like we'll definitely throw that stuff out. All right, so the general proof of E equals mc squared remained elusive until 1911, when Lau finally derived the mass-energy relation for an arbitrary closed static system that is the system with a time-independent energy momentum tensor containing the electric and mechanical, elastic, uh, chemical, and thermal energies and stresses whatsoever. Wait, hold on a second. Any system with a time-independent containing. Okay. Um, his proof exploited Minkowski's tensor formalism. It was concise and elegant, and avoided the tedious dynamical details that had frustrated Einstein. What dynamical details were frustrating him? Do you ask? We will get into that shortly. Don't let me forget. Somebody remind me. I have super ADD. Um, it's important. So Lau integrated the stress tensor here, and this is the early rendition of what it used to look like. It now looks like T subscript UV. So when you see that, it's just the old rendition of how it used to look. So he just wrote it like that. So TUV, the components of the energy momentum tensor over the volume of the system obtain the total energy and momentum. He showed that for a closed static system, the conservation law, and he's got some rendition of TUV there, implies that the volume of the integral system is just are equal in the rest frame. So he's basically was making the inertial mass, or like the rest frame mass, proportional to the energy mass scaling, where they're tied together. Because in classical mechanics, they're not tied together. What something weighs is what it is. That's its mass, right? It's not when it's moving. It doesn't have a different mass, right? But in relativity theory, they're tied together. So as you move faster, your mass increases, right? So that's where you get into the whole paradox of, you would need infinite energy to move at light speed if you have mass. Therefore, that's why the photon doesn't have mass, but it has momentum, like blah blah blah, right? So all that kind of stuff. That's where all that's coming from. But to describe physical objects, right, you're going to need to be able to dynamically describe their the mass in their rest frame, right? Because when you're doing dynamic predictions and all that, everything has to come from the rest frame. So it's all going to start with a mass that's going to not be able to be satisfied by conservation laws. Um, because in classical mechanics, um, the way that they would solve it, they would say they have an equation for it. So like E equals mc squared, whatever, would be satisfied by what would it be? E equals pm, I think it is. So the momentum would be like it would be proportional, right? In its rest frame, it's satisfied, right? But because they're tied together now in a special relativity coordinate system, um, he needs a new way to satisfy the conservation laws. So that's where your boy's stress tensor comes in, and that's where this TUV that we're going to go over later comes in, and the importance of the first order intrinsic differential invariant will come into play, and you're going to see that like while it satisfies dynamic predictions, it does it through abstract kinematics that makes no sense to the coordinate system and and will actually render the whole process physically meaningless. So like cool for us, not so much for the people that believe in relativity theory. Um, so that was the struggle here that he was going through, is satisfying the conservation laws with this stress tensor. And I actually have a presentation that I'll have a link to about covariance, and I go over the history of Einstein's uh, uh, the evolution of the transformations, right, from the classic algebra that he was using for the Lorentz transformations up to the tensor calculus, where he gets into absolute differential calculus, and he starts using these tensors to conserve things. And what are the rules for all that sort of stuff? Because it turns out that there's like very specific rules for all these things, and if you don't follow the rules, then your equations are just for funsies, basically.
So you're saying basically that
So.
the kinematic equations end up not even working out.
the he has to like make mathematical violate like dimensional violations to like even facilitate the appearance of satisfying the conservation laws within the system.
Gotcha.
Yep. So I'll get into what that means towards the end here specifically. So let's see. From the Lorentz transformation properties of the components, the energy momentum tensor, he was able to prove that the volume integrals for the TUV components of the momentum tensor transform as a four vector. That is, the total energy and total momentum of the system transform as a four vector. All right. So he was able to make a successful transformation using uh, the stress tensor, sometimes referred to as the pseudo tensor. And the pseudo tensor is, well, the history of it is because it's ad hoc, and we'll get into that anyway. So in the last two papers, so this is still from Ohanian. In the last two papers, I equals mc squared in 1935 and 1946, Einstein reverted to the mistakes of his earliest papers. In 1935, the paper which published version of Josiah Willard Gibbs lectured he delivered in Philadelphia in 1943, he again assumed that without any justification that the energy and momentum of a system have a particle-like dependence on velocity. And in his 1946 paper, he repeated the exact same mistake in 1905, and this is again where he dealt only with the low speed approximation, but now but now he performed the calculation with the momentum change produced by the emission of the two light pulses rather than with the energy change as in 1905. So trying to satisfy everything from different perspectives and accounting for the momentum in different ways, or actually trying to get away from accounting for the momentum really, because with the proportional relationship with mass and energy, he was really struggling with that and satisfying this pseudo tensor situation. Now, the mainstream narrative will be like that he definitely like nailed it and was able to satisfy this. He wasn't, and it haunted him forever. Um, so that's cool. So in these mistakes, Einstein did not have a solid claim on the mass energy relation, neither terms of priority or in terms of the proof. So very cool analysis. And then this is just a quick excerpt on each paper that he submitted and what he didn't do correctly to derive the effects, or to show that he was deriving it in a meaningful way. So 1906, Einstein analyzes the motion of the center of mass of a system containing several small bodies of electric fields, includes electric field energy in his definition of the center of mass, but treats the contribution of mass of the moving bodies as non-relativistic, so the slow approximation stuff, and only considers their rest masses. So he's trying to, um, even he's like, we gotta hit these rest masses, boys, because like without that, like what are you doing? If you can't show that dynamic and kinematic relationship with your theory, then it's purely just kinematic, then, right? So that's where he was at with that, or that's how he tried to present it, like as if he was accounting for these things, but it turns out he wasn't. So Einstein failed to examine the contribution of the detailed velocity dependence on the kinetic energy, and his own result is only approximate with his first order slow slow velocity approximation or whatever, right? So in 1907, so this was part one of a submission. So he analyzes the extended system consisting of an electric field and the charges, and held in a static equilibrium by a rigid mechanical framework. So this is where he just imposed some conditions to try and get what he could out of it. He then recognizes the presence of the mechanical stress increases the kinetic energy of the system. He makes the mistake again, or makes the mistake by assuming the kinetic energy of the extended system has the same simple particle form that has the single particle. So the second submission, part B here, Einstein modifies his 1905 work by changing the energy of the system with the action of an external electric field. Similarly to the 1907 paper, he assumes the kinetic energy of the system has a simple particle-like form. So what would that be? So is he not sure? He's trying to basically just use the rest mass again, I'm assuming. So these assumptions were criticized by the lack of rigorous bias. And this is just summaries from the from your boy Ohanians, because he goes over each one of the submissions in detail. I'm just kind of giving a rundown of them. So let's see. So this is an unpublished manuscript from 1912. It got published much later, I guess, in an attempt to explain the relativity. The critiques here are that it includes the same mistake as the 1905, assuming the kinetic energy of the system has a simple particle, just not accounting for the relativistic mass in the way that he says he is. Was there a question? I thought I heard a microphone.
Oh, sorry. I just kind of scoffed because they just keep doing the same thing.
Oh yeah, you're good. Yeah, he just kept. He's like, guys, is it this one? Like, no, I'm sorry, Ein. So in his 1935 paper, Einstein then assumes the energy and the momentum of the system have a particle-like dependence on velocity. Again, assumption lacks proper justification and proof. And this, and then to like look at the mathematical derivation of this, like the breakdown of that. That's where your boy Ives comes in, and with that appendix of his paper review, you can like look at um, the analyzation of like, it's not logically consistent to say that you prove this relationship or that this is a relativistic effect based on the way you're trying to describe it through the mathematics, because you couldn't possibly logically connect the two, because you didn't do it mathematically, right? Or you didn't even do it mathematically, I should say. So then in 1946, Einstein repeats the same mistake, oh no way, as his 1905 paper, by dealing with the low speed approximation and performing the calculation with the momentum change produced by the emissions of two light pulses. This critique is that it approached it, that it's just giving more limited shit to fucking, pretend like he's accounting for everything, right? Very cool. So wrong for 40 years and still somehow right and given all the credit for it. And that's really cool. So this is an astonishing mistake All the more so because Einstein was aware of it but refused to recognize it for what it was. In a footnote in his 1912 manuscript, he highlighted this mistake. So remember his unpublished work that wasn't published until much later? So like how did he keep making this mistake? What was going on? So to be sure, so this is a footnote from that 1905 manuscript. To be sure, this is not rigorous because additive constants might be present that do not have the character of a vector, but it seems so artificial that we will not dwell on this possibility at all. So we're just gonna. Oh, sorry, I read comments. Uh, shit. There might be other factors to consider, and he doesn't even want to think about that kind of stuff if he can just get the math to work in the way that he needed it to, and then he never could for 40 years. So despite the admission, one second, Joey B, I'll hit you up in a second. Despite the admission, he persisted in his mistake that all revisions and republications of this argument were over the span of more than 40 years. He wrote down this argument in 1912 and included it in several papers on general relativity and in his book, The Meaning of Relativity, and revised. Yeah, dude, I love this. And revised the book in 4 subsequent editions, with the last of these in 1955, and he never corrected the mistake. That's what's up, bro. Revised the book 4 times, talked about the problems in it, never fixed it.
So the
That's
best he
like,
could ever do was to get approximations, and that was within very limited sets of variables.
yeah. So, and that was with his mathematical abilities. So like those other dudes were able to do it, but we'll get into the significance of that as well. But yeah, so he never was actually even able to just mathematically prove E equals mc squared in a relativistic frame.
Wow.
Yeah, but like, hey man, Einstein, bro, like that's what's up, bro. Because we're all told, like, nobody, like, we're not told any of this shit. We're just like E equals mc squared atomic bomb, dude. Einstein. The Big Bang
Yep.
Theory is on tonight at 9 o'clock on CSNBC or whatever it is. So here we have, by 1948, in a letter to Lincoln Barnett, Einstein denounced the use of the relativistic mass as it was being used in special relativity in a handwritten letter that is published in this part. So we'll read this in a second. So no way. Now he went from revising it in his book, not correcting it, to denouncing it. Well, actually, I think the book happened after this. Yeah, so he's like well aware of this situation. He's denouncing it, and then in his book, he's just like, fuck it, Really cool.
Can you drop that
So
screenshot in chat when you're done after the presentation?
absolutely,
Cool.
absolutely. So letter from Albert Einstein to Lincoln Barnett, 19 June 1948. Einstein wrote in German. The letter was typed and sent in English. The highlighted passage in this excerpt says, "It is not good to introduce the concept of mass, capital M equals m divided by 1 minus v squared over c squared times 1/2 of a moving body with no clear definition, or which no clear definition can be given." Say what, Einstein? you, you mean to tell me you have no reason for deriving that in your theory and making it a consequence of relativity or whatever? Like that's not an actual sufficient mechanism. Quote from the guy who allegedly made the theory. It is better to introduce no mass, or it is better to introduce no other mass concept than the rest mass. Instead of introducing m, it is better to mention the expression for the momentum of the energy in the body in motion. So the reason for separating this, is so that he could satisfy the conservation laws without using that pseudo tensor that he had to use, which is a first order intrinsic differential invariant, which I promise we'll get to the significance of at the end. Because this literally killed the whole thing. Like this people used to know about this problem with the tensor situation, but they just kind of swept it under the rug, don't talk about it, and it's lost to history. There's a couple other tensors that were derived subsequent to the to Einstein's stress tensor, and they say that these ones are the good ones, but though they're actually all derived from Einstein's uh from Einstein's tensor. I can't remember the thing for it, but he it's basically like it's just like it's just another reification fallacy, but they have another one. So they're like, this one's the good one. But what's going on is they're just facilitating like a fake way to conserve energy under certain coordinate system transformations, when in fact it's supposed to be invariant under all coordinate system transformations, according to the principle of covariance. So because if that's not true, then the whole theory is like bankrupt mathematically, right? All right. So why was Big Ein opting out of relativistic mass? Oh shit, I just kind of went over the whole thing. All right. So relativity requires different values for inertial mass of a moving object. Its direction its direction of motion and perpendicular to that direction. This contradicts the principle of relativity, and that the laws of physics are the same in all reference frames, all inertial reference frames. I should have said. Um, so E equals MC. Well, no, yeah, never mind. Let's leave it at that. So E equals MC squared produces non-invariant transformations for inertial mass and energy, which renders it untenable to satisfy conservation laws on the relativistic scale without supplemental stress tensors, which we're about to get into. So on the surface, E equals mc squared gives the appearance that the conversion of energy is satisfied by redefining energy as a function of mass to supplement the logical inconsistencies of the theory itself. After 40 years, what did Einstein bring to the table after deriving E equals mc squared as a relativistic effect? In his proof, the main contention is that while the total energy comprising both kinetic and potential energy remains constant, the potential energy can be interpreted as contributing to an augmented resting mass. This interpretation implicitly alters the definition of mass to align with the desired conclusion. All right. So, summary. Einstein made assumptions about kinetic energy of the extended systems having the same form as a single particle without solid justification for or mathematical proof of these assumptions. Lau and Klein, using conservation laws in the stress tensor TUV to satisfy them, E equals mc squared was mathematically proven with stipulations to be later discussed. Einstein never proved his assertion about E equals mc squared without circular reasoning, trying to derive the solution for what he had already assumed to be true. First order intrinsic invariant differentials are what were used to facilitate the appearance of mathematical covariance between the kinematic equations and the dynamic predictions that would have to come out of them. So if E equals m, then how is energy conserved in relativity theory? So there's a great video here that I'll link. Now, it's like 22 minutes. It's super dry, super dense, uses a lot of terminology that no one's ever heard before. But you can actually see the guy go through the mathematic process, because what we'll often see is like when you're going through a paper, you have like the finished product of it, you're just kind of looking at it. This guy goes through like actually contracting the tensor, goes through the whole process of what he's describing, and shows and shows the violations of it and the significance of this violation and what it means, right? So we'll go over some definitions here to supplement the video, and you guys watch this on your own time. I'm not gonna put everyone to sleep for 20 minutes and play it out, but here's some slides that give definitions and context to what he's talking about. So when you listen to it and watch him go over the equations, you can reference it and go, oh, okay, so this is what he's talking about. This is what's happening. This is what these words mean, right? Because if you don't, because I watched this a bunch of times before I knew what the words meant, and I'm like, okay, cool. First order, who, So definitely, when you learn what he's talking about, uh, it's crucial to relativity, because it's this distinction between kinematics and dynamics, where it's like, are these equations physically meaningful? Does time really slow down? Does length really contract? Did, you know, does does the order of events really depend on relative motion between observers and who's observing what? Like, or is there a cohesive chain of events, right? So all of this comes out of the mathematics, and so the analyzation of this is like done in the language of, mathematics and the descriptions of all that. So you got to kind of get familiarized with some of the definitions. So covariance would be used to describe a tensor that transforms in accordance with coordinate system transformations. So let's see. So when you transform the laws of physics, right, when they're represented by their little letters and stuff like that, right, these they have to be their values and stuff have to be invariant under transformation, meaning they can't change. Otherwise, the laws of physics wouldn't be the same in all reference frames. And the first postulate of relativity theory slash the extension through the covariance or through the general principle of covariance wouldn't be satisfied because the laws of physics would be different in reference frames, and that's not what relativity theory is all about, right? So there's rules that govern these transformations and how they analyze them and how they assume the validity of the transformation because what's the word for it? A transformation, to a different coordinate system, right, is just a hypothesis waiting to be verified experimentally, right? Because you can say, you can make the math check out, but it's like until you have someone there to verify the experiment or make the observation to confirm, you know, the difference between the two reference frames, you really can't do anything other than satisfy it mathematically. So there's a pretty rigid rule book to it now with the extension in general relativity to the covariance principle. Einstein broad stroke made all reference frames and all transformations covariant. So the special theory was only applicable to Lorentz transformations. So with the general theory, Galilean transformations, like all the laws of motion for like Galilean velocity addition, all that kind of stuff would still be applicable in the general or through the mathematics of the general theory, because that's where you get into the tensor calculus, where you have the freedom of swapping in these different tensors and how they relate to satisfy what gives the appearance of satisfying covariance. But when you do a dimensional analysis, like your boy um, Stephen Crothers does, uh, you find that it doesn't properly satisfy the conservation laws. It just gives the appearance that it does on the surface level, that they're not actually physically meaningful transformations. So let's see, invariant means the quantity remains unchanged under transformation. Example, the speed of light. So the speed of light can't change. So when you transform in coordinate systems, the speed of light would have to be the same. And that kind of makes sense. So and how they get away and how they facilitate that mechanism, right, is they contract the coordinate system hyperbolically, right? So if you think of a coordinate system, an X, Y, Z axis, let me pull this up real quick. Covariance. Nice. Okay, so if you look at an XYZ coordinate system and you just add another axis, you just add t to your what would that be? Your y axis, right? You just throw a t up there for time. You just add an additional variable, and you say in the direction of motion that t will contract hyperbolically, and that's what this Minkowski space-time diagram is right here. This is a hyperbolic contraction between space and time to meet the speed of light to facilitate the invariance of the speed of light. So when they do a transform, because so like they talk about relativity as if it's a theory about the speed of light, but really it's a theory about adherence to a belief in contractions, because if length and time do not contract and dilate, then the speed of light varies in inertial reference frames, and there's no way to explain that mechanism. And then that gets into the Michelson-Morley blah blah blah, right? So it's really a theory. It's really a contraction theory, and that's the relationship drawn here. Shout out to Minkowski for geometrically expressing covariant transformations through this light cone, where any cohesive chain of events that doesn't violate causality is automatically covariant, because of this hyperbolic relationship with how fast you're moving will be how fast time is dilating with that relationship, right? Very cool stuff. So that was to show that. And then so some of these tensors, this is what they look like. The Einstein tensor. So if you see this in equation, G sub UV, the pseudo tensor, the TUV. So this is your conservation tensor that he used to derive. So what he did is he actually derived this tensor from where is it at? From this little baby GUV, and you can't do that. It has to come out of, I believe, this one instead. It has to come out of the big G. So if it doesn't come out of the big G, you're just shitting yourself. So let's see here. There's covariance. And then you can look at the screenshot for the rest of the definitions and all that. So let's see here. So a second order differential equation, real quick. So a second order differential equation is a mathematical equation that involves a function, it derives, or its derivatives, and its second derivatives. Einstein's field equations are second order differential equations that describe a relationship between space-time curvature and the distribution of mass and energy within it. The curvature of space-time is affected by the presence of matter and energy, which are the same thing in relativity. And the field equations provide a framework for understanding that relationship. So when it comes to the first order intrinsic, or the first order intrinsic differential invariance in that situation, right? So you have this overarching structure of the system, right? So if you think about that like a sphere, right? So you're going to say, here's the boundaries of the coordinate system, and blah blah blah, right? And then from this system, you're going to derive like smaller segments of like localized segments of that coordinate system, right? So when they talk about like if you zoom in an infinitesimally flat part of space time and all this shit, what they're doing there is they're like zooming in from the bigger framework to the smaller framework, right? Now, when you're in that smaller framework, like when you're in the smaller sphere that's derived from the bigger sphere, you have to make everything dimensionally the same. Your conservation laws and all that stuff have to come out of the field equations from the overarching structure of the mathematical system, right? So that big G, where was that? Yeah. So if it's not coming out of that, then when you get into transformations, you're only going to satisfy the conservation laws under specific transformations. And Einstein's the big bolster of the general principle of covariance, like that expansion pact to Lorentz symmetry, is that all frames are equally valid under general relativity, and you can just, you can satisfy them with whatever, right? So how they do that is by swapping in these different tensors and stuff. But what actually happened was they couldn't satisfy the conservation laws because of this mass energy equivalence from here, right? From the big structure. So they came up with a way to satisfy it from the small structure, from like self-deriving it from that. And that's a huge mathematical violation, because when you go through the process of contracting the tensor, meaning when you impose conditions on it and then do a transformation, you're not going to get invariant results, and that's going to violate covariance. And if you violate covariance, then you're like that's literally violating the mathematical framework of it. And because it's all mathematical, then you're just making shit up, basically. You know what I'm saying? So that's the quick rundown on everything. How are we, boys? Where are we at? Is everyone asleep? What's up?
Uh, this is fantastic. I am super happy to have these definitions because they're words that I've been hearing and even throwing around a lot, yet like only have loose. It's going to be good for me to spend some time making sure I understand fully all these definitions.
Yeah,
Dude,
definitely,
it's
man.
almost like.
Go ahead.
Sorry, my bad.
Oh, you're good. Go ahead.
You're straight.
I just was gonna say it's almost like you're finding where they're like they couldn't explain it. And they're like, "Oh, don't worry, we'll come back later." Like it's
Yeah.
all
Yeah.
cool.
Well, this dude lost his whole career over it. He was his PhD candidature was in a mathematical analysis of relativity theory in this pseudo tensor situation. And what he stumbled on is like this was already figured out by I think I have, or I don't have the citations here for this one, but this was already figured out by people, and this was a big thing. I have some Russian uh guys, I can't remember their names off the top of my head, but like these guys did analysis on all this stuff and already figured all this stuff out. And this guy was just kind of like bringing it to the forefront, but like not even intentionally, like from their work. He was just he had the mathematical wherewithal to like understand it, and was like, oh hey, by the way, like this doesn't. If you do this, like this make and he was like, yeah, dude, dude, exactly, bro. And he found out real quick that that's a no go. And yeah, so like I have a couple videos on his career because he details it, and I just kind of like read over
Wow.
the history of what happened, and how he got expelled from he got dropped from his candidature He lost a sponsor, so he couldn't complete his PhD. And this dude is like, I mean, he does the math, like literally watch a video of him doing it. So like this tensor contraction situation that I was talking about, 18-minute video, your boy contracts the tensors, exposes what's going on in the situation where they're like, no, we fixed it with another, what is it? The Landau-Lifshitz Fitzgerald tensor. It's like, no, that's also a first order differential intrinsic, or I'm sorry, a first order intrinsic invariant differential or differential invariant as well. So like, GG's all around.
It's just like it's I don't know. It's like black magic in a weird way. It's just like
Yeah.
fake explanations of things. It's crazy.
Fake explanations. My favorite quote is like Einstein's like, dude,
Yeah.
with no clear definition can be given. What? Say what? Yeah, man. Very cool stuff. So shout out to that guy from Flat Earth Friday that motivated me to turn my eye of Siron, on this E equals MC squared situation, because it turned out to be way more fruitful and relative to the conversation than I could have ever imagined.
Yeah, this is awesome. I can't wait to see you develop it more because there's a lot of good stuff in there.
Yeah, this is just the stuff I put together in 2 days. So, and then obviously, like I already had like the back end or the back knowledge information on some of a lot of this, but this is just stuff that I found over 2 days and put it together. So, yeah, it's now been weaponized, as they say.
Yeah.
So, very cool.
Yeah, this is the first deep dive I've ever heard into the E equals MC squared thing. So good work, man. I'm gonna have to re-listen to this, but a lot of good info. Very, very interesting.
Yeah, cool, man. Thank you. Yeah, it's all new uncharted territory type stuff, man. Because you don't really get people that will speak out about it, even though they know and the information kind of exists out there. But it's like to get it all together and disseminate it. It's like, it's a lot. I'm just glad that it's that it makes sense. Right?
And then before the veils pulled back, you kind of look at all this stuff like E equals MC squared, like, oh, I'm not smart enough to look into that. I'm gonna leave that for the PhDs, and I'm not even gonna touch that. But once the veils rip back, kind of take a deep dive in, and it's like, oh, I see what's going on.
That was my entire mentality as a globularist enthusiast when it came to relativity theory, because I was like, I love black holes and shit so much, and I just believed in Einstein shit, because like everyone else did, had no reason not to, right? But like every time I tried to learn about it and understand it, it was like, yeah, I don't care. Someone already figured it out. It's fine. Like, because it's very complex. You get all these different narratives. It's confusing. Like different experiments have different interpretations depending on which coordinate system you're referencing. It's like, how do you navigate that system without going through like some sort of curriculum training pipeline to like go through the mathematics as well? So it's like very hard from an outside perspective. But it's like when you go through the historicity of the narratives and like what the equations mean, what these letters mean, how they're used, what they're meant for, and all that, you're like, oh shit, this is what they're saying. These are the problems. Like it starts to make sense, but it's like literally learning a second language.
Yeah, that's what I'm saying. Like, I'm so excited about these definitions because it's gonna help me to express this so much better once I get that down. Because it's hard to communicate some of this stuff.
Yeah, this is an awesome stream, man. Thank you.
Yeah, no worries, man. We do them. Hopefully, we're gonna be doing them every week.
Yeah, I don't know about Mondays. It might not be the best day.
Yeah, probably not on a Monday.
But I just wanted to get another one on the schedule. But yeah, every week I think is probably what we'll do here. Probably do the next one next like Wednesday or Tuesday.
Cool.
Yeah, sounds great. This is my first time on Discord. I just downloaded it and got on. So.
Oh, awesome! Welcome, man.
Yeah, thank you guys.
Welcome. All right. Did anyone else have any questions, comments, concerns, feedback, input?
Yeah, dude. The only comment I have is it's amazing that the heliocentric model is a prison for the mind, a false reality of where we live. And then in the upper echelons of different sciences, there's just been protocols and mathematics and theories and philosophies built in to where these folks that are very talented and skilled and doing their best to understand this setup, it is also imprisoning. It's like pride and ego build, and they really know stuff, but they don't because it's not based on reality, and that's really crazy. Just imagine if all the energy over this whole time had been harvesting energy, out of the ether. Right now we got these like ugly telephone lines running around everywhere just to show us like, oh, this is where the power comes from, from the power plant down every street, when really power shouldn't be something that we have to pay for, yet everyone's fooled. It's just amazing stream, a lot of information. I have to learn what I need to unlearn and then start working on what we need to learn in this realm. So thanks, Alan.
So you
Yeah,
just
bro.
pinpointed the exact reason they don't for the intentional confusion. That's the reason they do that. So
Yeah.
that you won't focus on free energy and all that kind of stuff. Yeah, ether is dangerous. Dangerous information, boys.
Dangerous information.
I'm glad you're talking about it.
Yeah. Yeah, it's been a wild ride, man. I went from like is like, oh cool, it's a potential framework of interpretation that doesn't really have any physical meaning. It's just something that, it's just another way to look at it. To like, oh yeah, these are like physically measured effects. Like this is the mechanism for, it's been awesome to like uncover what's been obscured and hidden through history. Where they now just attribute these things to as like relativistic effects, where they don't even address them properly at all. And it's like, yeah, it's definitely ether, right?
Yeah, just the simple fact that everything's connected through a background medium. No big deal.
NBD, no significance here, so no significance here. Let me hit up the YouTube chat.
Did you already go over the Brenner stuff? I was driving and I couldn't really hear very well what you were.
Negative.
Oh, you didn't do your Brenner thing. I thought that was in your lineup, and I first heard you talk about what you were going to talk about.
Brenner.
Oh yeah, didn't you? I think you might have said something about that. Yeah.
Brenner. No, wasn't me, bro.
Oh, I think I thought you said something. It doesn't matter. I thought you were going to bring out Brenner's contribution to the thing that you had posted earlier.
No, what?
Talking about, you had an excerpt from Brenner and you said GG underneath it concerning Einstein? No? Okay.
Oh, in our private chat?
Yeah.
Oh, hold on one second.
Let me look. Yeah, the other chat. The other room.
Yeah.
I thought that was in your lineup because I think Toby's right. You said something like this and then Brenner and then.
Oh, okay. Yeah. Let me.
I mean, either way, we should talk about. There's this could go on all night easily.
Yeah, I don't know. I'll have to look.
By the way, I just messaged him. I'll send you a DM of the message I sent him just a little bit ago when Toby and I were DMing about trying to get a hold of him. And I invited him to this. I said, oh, obviously you're not going to make it for this. It's like in a half hour from now. But, if you're on Discord or is there anywhere else on the internet that we can find you talking or participating or writing or anything? Trying to figure out if there's an actual Michael Brenner legend in some of these other guys that are referred to as Michael Brenner. He's the actual person.
Nice.
That'd be so cool if we can get him into a discussion.
Toby just reached out to him, but I think he got the wrong email address, he said.
Yeah, where'd you get the email? Where's that from?
Last week, someone went to his they looked up Michael Brenner and went to a web page and said like, oh, there it is. That's his email address. I don't remember who it was. So I went and grabbed that one, and I was like, and then I emailed it, and then I realized, oh, that's definitely not him.
As far as I can tell, I don't think any of the other people that you can find as Michael Brenner outside of Quora are the actual Michael Brenner.
No, the only hint he gives is that he studied at Vienna.
And there's one Michael Brenner connected to Vienna University,
but not him.
So it seems like it might not be him.
Yeah, it didn't seem like it from what I could tell.
Yeah, the profile doesn't fit. And then there's a guy that works for Jet Propulsion Laboratories. And I
Well,
don't think
hey,
that's him either.
we're still live, so maybe we should err away
Yep.
from accidentally doxing him.
Well, I mean, anybody can find that information, and I'm
For
saying
sure,
I don't
for
think
sure,
it's
for sure. I'm just saying we
But,
should probably. Oh, this is a good video.
because I did tell him about this live cast. Please come talk to us. That'd be great. We're all about the ether, and we know you know about that. So
Yeah, that'd be amazing. This video is
what's
really
the-
good.
what's the excerpt that you thought to mention, though, Alan? Are you ready with that, or?
Oh
You're
no,
talking
I have
about-
no idea. No idea
Oh,
what
okay.
you're talking about.
Never mind. That's fine.
Like I went back to read our PM or whatever, and I don't remember. I don't even see where.
No, it was in the other. It was in ADL. You posted something in there, and I said, "Is that from?" Oh, and then then I posted it back to you in ADL. I said, "Is that from Michael Brenner thing that I sent you?" And you said yes.
Oh, okay. Hold on.
Induction and
I didn't-
atomism are incompatible.
Is that what I said? Oh, here we go. There we go. Induction and atomism are incompatible. You have to divorce all your notions of photons, electrons as particles, and with the entire fantasy of the particle zoo of CERN is producing. Take a handful of spaghetti and break it in half. This is what I love the most right here. This is good shit.
Yeah.
So take a handful of spaghetti, dude. Thank you for bringing this up because I was trying to remember this analogy and I couldn't remember where I read it from, and I was like something about breaking spaghetti. Thank you.
There you go. All right, good.
So take a handful of spaghetti and break it in half. What you see is a bunch of terminal ends of the spaghetti. So clearly you see something which you can name, and describe, but a terminal end is not the thing itself. That's how it works with particles. They are the terminal ends of lines of induction, not something with an autonomous existence. CERN is doing nothing but breaking spaghetti and giving the terminal ends names, and the more energy they pump into their apparatus, the more spaghetti they break. But one wouldn't call that a path to discovery, would one?
There you go.
Yeah, that's such a great actually I need to add that to the prez. Where should throw it in here for ending summaries, maybe? Yeah. Shout out to your boy Mike.
Yeah, he's great with the wording, and his style of writing is entertaining. And I can't remember him mentioning any kind of ether win, which I did mention in the comment section that I sent him. So I wonder if he's even onto the ether win tip or some of the Dayton Miller stuff or any of that yet.
Yeah, I thought it was cool that
sure.
you're so familiar with his work that you were able to share with him something he may not be aware of.
I think so, yeah. At least I haven't heard him mention it or go into that detail of Michelson Morley, being tested that many times, or even to mention the name Dayton Miller or Wang or any of these other guys.
Yeah.
So that maybe he'll come in and be like, "Oh my God, you guys are stepping it up, and I didn't even know about who you were." Yeah, let me DM you the message I sent him. Actually, I'll do that right now.
Nice.
Well,
All right, so I think oh, sorry, go ahead.
No, good.
I was gonna say I think with that I'm gonna go ahead and wrap up my stream. I
Yep,
think.
same here. It works out. Thanks
right.
everyone for listening. Really appreciate
Yes,
having everyone here. Feel free to keep hanging out, obviously.
Yeah, thanks for the stream, guys. Thanks for having us.